Proving triangle congruence by side, side, side. The side, side, side congruence theorem states that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So let's look at this. We have congruent marks so that side DF is congruent to side HI. Now, we continue looking and we see that side FE is congruent to side HG. And then we can see that side DE is congruent to side IG. So that shows that our three sides of each triangle are congruent to each other. This tells us that triangle FDE is congruent to triangle HIG. If you'll notice, right here, I have side DF here and side HI here are congruent to each other. We stated that. We also have stated that side FE and side HG are also congruent to each other. Finally, we stated that side DE and side IG were congruent to each other. Now, I'm making a big deal about that because it's extremely important when you write congruent statements that you pay attention to how it's written. The corresponding angles and corresponding sides must be written in the same orders in the both triangles. Okay, now using the side, side, side congruence theorem, we're going to write a proof. Now, the very first thing that we need to do is we need to look at what we have available to us. Now, first of all, AD is congruent to AB, and that is given information to us. Now, that gives us one side, so we're just going to put an S right there. Now, we also have DC is congruent to BC, and that looks like that is also a side, and so we're going to go ahead and put an S right there as well. Now, we need a third side to be able to use side, side, side to prove triangle congruence. So we're actually looking, we need this side. This side is congruent to itself, and we know that because of the reflexive property. Now, let's set up our proof. So we have statements, and reasons. Anytime you're asked to write a proof, you set up these two columns. It's called a two-column proof. And also be sure to number each step. Number one, our given information is that side AD is congruent to side AB. And that's given information. We number it so we know what reason goes with what statement. Next, we have more given information, so we're just going to put a comma here. And we're going to add this to our first statement and say that side DC is congruent to side BC. And that's also given information. So you don't actually have to make a new statement for that. Number 2, and this gives us one of our sides. This gives us our second side. Now, our third one is that AC is congruent to itself, AC. And that is the reflexive property. And that actually gives us our third side. So our final statement is what we're trying to prove, that triangle ACD is congruent to triangle ACB. Our reason for that statement is the side-side congruence theorem. You can label that just SSS. Using the side-side congruence theorem, what additional information is required in order to know that the triangles are congruent by side? Now, sometimes you're going to be asked this question and you have to look at the information that you're given and determine what you need to know. Now, in order to be able to use the side-side congruence theorem, we have to know that all three sides are congruent. Well, we can look at our picture and we can see that side RQ and side DS are congruent with each other. They have the markings. We can also look and see that side QS is going to be congruent to itself because of the reflexive property. However, what we're missing is RS and it being congruent to DQ. So the information we need is to know that RS is congruent to DQ. This information has not been provided to us, so it's the information that we can't get on our own, and we would need to be given that information. We aren't given the side QS, however, we can deduct what it is because of the reflexive property. Next, we're going to check out the hypotenuse leg congruence theorem. The hypotenuse leg congruence theorem states if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. Now, if you look at this, we have two right triangles, which is the very first thing that you need for this congruence theorem. So the very first thing we need is a right triangle. And then we need to know that the hypotenuse is congruent. Now, this one does not have it marked. We're going to go ahead and say that it is, so that will be given information because I'm giving it to you. So we have our hypotenuse. Our hypotenuse is the hypotenuse is congruent, and one leg is congruent. The leg is this one here. Remember, the legs are the two sides that make up the right angle. So we have our hypotenuse, and we have our leg, and we have our right angle. These are the three pieces of information that we must have in order to use the hypotenuse leg theorem. However, we do know that because we have a leg and because we have the hypotenuse, that we can use the Pythagorean theorem to figure out the other leg. Because we have a square and we have c square, now we can find b square. And in that way, this theorem is related to the side theorem. Because if you have two legs of a right triangle, you can calculate the third leg. Now, we're going to use the hypotenuse leg congruence theorem, and we're going to write a proof. So the first thing let's look at our given information. ABC is an isosceles triangle. Well, that tells us a couple things. We know that in an isosceles triangle that there's two congruent sides, and these are the congruent sides because if you notice, C is a vertex angle. Now we also can look and see that CM and AB are perpendicular. That's what this little symbol means. So that means that's going to give us a right angle in those two triangles. So if we look individually, we have this triangle here. Let's look at it. We know that it is a right triangle, and we also know that it is part of an isosceles triangle. Now, the isosceles triangle has two congruent sides, and these are the hypotenuse for the right triangle. So this first part gives the hypotenuse, and the second part gives us the right triangle. Now, let's look further. We're going to write our proof. So we set it up, 2 columns. We have our statements. And we have our reasons. Our first statement that we're going to put down is that triangle ABC is an isosceles triangle. You can go ahead and abbreviate that word isosceles, and that is given information. So that's all we have to put for that. Now, number 2, we can say that AC is congruent to BC. And we were able to say that because of the definition of an isosceles triangle. And that gives us the hypotenuse. Number 3, we can say that CM is perpendicular to AB, which is also given information. Now, when we write that, we can also state, because of that, that ACM and BCM are right triangles. And the reason that we can say that is the definition of a right triangle. That also gives us our right angle. So we've got the hypotenuse and we've got the right angle. But now we have to look for a leg. Now we have one right here, and we have that because of the reflexive property. So number 5 would be that CM is congruent to CM, and the reason for that is the reflexive property. That statement gives us the leg for the required information. So we can now say that we have proven that triangle ACM is congruent to triangle BCM, And our reason for that is the Hypotenuse Leg Theorem. Go ahead and pause the video and do this proof on your own, and then come back and we'll check it together. Now let's look at the hypotenuse leg congruence theorem to use to write a proof together. The first thing that we want to look at is that we have SR is perpendicular to RT. So that means that we have SR, which is here, that is perpendicular to RT, which is here. Now, because we have so many overlapping triangles, I'm actually going to draw it out to the side for you so that we can identify what it is we're actually looking at. Now, the first triangle is TRS. That's the one we were just looking at. And then let's label that S, R, and T. And then beneath that, we will go ahead and draw SUT. And we'll label this one. Now, in the first triangle, we are showing that SR is perpendicular to RT, which means SR is perpendicular to RT. So we're going to label that as a right angle, because anytime you have two lines that are perpendicular, they form a right angle. Now, second of all, we have TU is perpendicular to US. So here's TU, and here's US. So those two are perpendicular, which means we have another right angle. So that tells us, first of all, that we have two right angles, which is the requirement for a hypotenuse leg. Now, next we know that SU and TR are congruent. So SU and TR are congruent to each other. Now, I put the second one because if you look at our original set, you will see that ST is on both triangles. And remember, this is the one that makes it congruent to itself. So that's going to give us a side. So we have, or a hypotenuse. Now, we have the hypotenuse, we have the leg, which is here. This is the hypotenuse. Remember, the hypotenuse is always opposite the right angle. And we have our right angle for our right triangle. We'll label hypotenuse up here. Now that we have all three components of the proof, of the theorem for the proof, we can write out our proof. And remember, this is called a two-column proof because there are two columns. The first column is statements, and the second column is reasons. Now, a lot of people think that these are hard, but they're not. Every time your teachers have asked you why you can do something and you give the reason, then you're doing a step of the proof. Now you're just writing it down. So the very first thing we're going to look at is SR is perpendicular to RT. And TU is perpendicular to US. Now, these are given information. Second, we can say that TRS and SUT are right triangles. So triangle TRS and triangle SUT are right triangles. Now our reason for this one is by definition, we're going to abbreviate, of right triangles. Now this one actually gives us our right triangle that's required for the hypotenuse leg. Next, we have SU is congruent to TR. Number 3, SU is congruent to TR. Now, this is the one right here that we said they are congruent. And that was given information. So we'll put given on this side. And this gives us our leg for the required information. Next, we look at number 4. Number 4 tells us that TS is congruent to ST. Now, the only reason that we're reversing that is because one triangle is facing one direction and one triangle is facing the other. Number 4, that is the reflexive property. Remember, that is the one that tells us that a line or a triangle side is congruent to itself. And this one is going to give us the hypotenuse because it's the side opposite the right angle. Then finally, number 5, we put that triangle TRS is congruent to triangle SUT, and number 5 is the hypotenuse leg theorem.